Real numbers. Euclid's Division Lemma. Euclid's Division Algorithm. Objectives. Euclid's Division Lemma. Euclid's Division Algorithm. Finding HCF using Euclid's Division Algorithm. To find the size of the largest square tile needed to pave the floor of a room, given the length and breadth of the room are 24 meters and 60 meters. Also, find least number of square tiles needed. Constraints. 1. It's allowed to cover the surface larger than the floor, but the floor has to be covered. 2. It's not allowed to break the tiles. 3. The sides of tiles should be parallel to the sides of the floor. To solve this kind of problems, we need to learn Euclidean Division Lemma. For example, consider the pair of integers 18 and 5. We can write 18 is equal to 5 multiplied by 3 plus 3. Here we observe that 5 goes into 18 3 times and leaves a remainder 3. Let us take another pair of integers 6, 13. Now we can write 6 equals to 13 multiplied by 0 plus 6. Here we observe that 13 is greater than 6. So, the relation holds. And let us take another pair of integers 25 and 5. We can write 25 equal to 5 into 5 plus 0. Here we observe that 5 goes 5 times into 25 and leaves no remainder. From the above pair of integers, we observe that for each pair of positive integers a and b, we found whole numbers q and r satisfying the relation a is equal to bq plus r, 0 less than or equal to r less than b. And we observed the following points from the above examples. 1. Either q or r can also be 0. 2. Q and r are unique integers. 3. Restatement of the long division process, q and r are called quotient and remainder respectively. Let us now give the formal statement of the result. Euclid's Division Lemma. Statement of Euclid's Division Lemma. Given positive integers a and b, there exists unique integers q and r satisfying a equal to bq plus r, 0 less than or equal to r less than b. Euclid's division algorithm is a technique to compute the highest common factor HCF of two given positive integers. Recollect the following. HCF of two positive integers a and b is the largest positive integer d that divides both a and b. To obtain the HCF of two positive integers, say c and d, with c greater than d, follow the steps. Step 1. Apply Euclid's division lemma to c and d. We find whole numbers q and r such that c equals to dq plus r, 0 less than or equal to r less than d. Step 2. If r is equal to 0, d is the HCF of c and d. If r is not equal to 0, apply the division lemma to d and r. Step 3. Continue the process till the remainder is 0. The divisor at this stage will be the required HCF. Illustration. Use Euclid's algorithm to find the HCF of 867 and 255. Here, from the given positive integers, we observe that 867 is greater than 255. So, let us take C equal to 867 and D equal to 255. By Euclid's division lemma, we have 867 equals to 255 multiplied by 3 plus 102. Here we observe that remainder is not equal to 0, so let us continue the process. Again, by using Euclid's division lemma, we have 255 equals to 102 multiplied by 2 plus 51. Here, we observe that remainder is not equal to 0, so let us continue the process. Again, by using Euclid's division lemma, we have 102 equals to 51 multiplied by 2 plus 0. Here, we observe that remainder is equal to 0, so the procedure stops and the divisor at this state is 51. Therefore, HCF of 867 and 255 is equals to 51.